Good day. Today's discussion will be stoichiometry. Stoichiometry is the study of the quantitative and measurable relationships that exist between the reactants and the products in a chemical equation. Some of the relationships will include the molecule of the reactant and the molecule of the product. Another one is the molecule of the substance of the reactant and also the mass of the product. Regarding the mass, you need to calculate the molecular weight, the molecular mass or molecular weight of the substance. Next will be the mass of a given reactant and also on the mass of a given product, which also includes the molecular weight of the given product. The last relationship will be mass of again the reactant and the volume of the product. Regarding the volume, you need to consider that one molecule of a given gas is equivalent to the 22.4 liter of every gas. Okay, let's have some sample problem on the first mole and mole relationship. In the equation, zinc is reacting to hydrochloric acid, giving you a product of zinc chloride plus hydrogen. Zinc, always remember that your zinc is 2 positive and chlorine is a 1 negative by oxidation number. And this is the crystals that zinc chloride will be zinc Cl2 plus the hydrogen. It's a diatomic, so you put 2 after hydrogen. In the given sample, you have 2.3 molecule of zinc. 2.3 molecule of zinc was given in the reaction. So zinc 2.3 molecule of zinc reacted to hydrochloric acid. And we're supposed to look for the molecule of our HCl. Okay? In the given equation, 2.3 molecule of zinc reacted to your hydrochloric acid. Now, in the balancing, you have 1 molecule of zinc and 1 molecule of HCl. This is now considered the coefficient based on the balancing of the given reactant. So 2.3 molecule of zinc in 1 molecule of zinc by balancing and 1 molecule of HCl. For the coefficient, 1 molecule is for the zinc, 2 molecule for the HCl to balance the equation. Okay? So we have 2.3 molecule of zinc reacting to your hydrochloric acid. 1 molecule of zinc in the coefficient and there are 2 molecules of HCl in the coefficient for the balancing. You multiply the numerator divided by the denominator and the answer is 4.6 mole of HCl. Now let us go to molecule and mass relationship. For the sample problem that was given, hydrogen is reacting to oxygen, giving you water. To balance the equation, you need to put 2 before hydrogen and 2 before water. The given was a 3.0 molecule of hydrogen. And we're looking now for the mass of water. For the balancing equation, we have 2 molecules of hydrogen coefficient and 1 molecule of the oxygen and 2 molecules of water. Since mass is being asked, we need to get per molecule the molar weight of water. Per molecule of the water is 18.02 grams. With the given 3.0 molecule of hydrogen, 3.0 molecule of hydrogen is given, and we need to consider the molecule of the coefficient of hydrogen, 2 molecule of hydrogen compared to the 2 molecule of your water. And we need to put water on top because this is the unknown substance. Then per molecule of your water is of course 18.02 grams water. Our final answer will be a multiplication of numerator over the denominator, giving us 108.12 grams of water. As a review for the mole-mass relationship, how many grams of water was produced in 3.0 molecule hydrogen reacting to oxygen? And our final answer was 108.12 grams of water. Now let's go to a mass relationship. Now let us go to mass relationship. In the given example, how many grams of water is produced from 1.5 grams of glucose? In the equation, there are 1.5 grams of glucose reacting to oxygen, giving you carbon dioxide and water. Now we are looking for the mass of water. For the coefficient, we have 1 molecule of glucose, 6 molecule of oxygen, 6 molecule of carbon dioxide, and 6 molecule of water. We need to consider the molecular mass of our reactant and product, of the given and the unknown. For the given glucose, per molecule of our glucose is actually 180 grams. and per molecule of our water is 18.02 grams. For our solution, 1.5 grams of glucose, H12O6. Okay. Considering 180 grams of glucose, H12O6. To be able to cancel the grams, that's per molecule of the glucose. For the balancing equation, we have 1 molecule of glucose, H12O6, to the 6th molecule of our water. The last part of the equation will be per molecule of our water is equivalent to the mass, molar weight of water, which is 18.02 grams water. Our final answer will be 0.90 gram water. For our review on mass-mass relationship, how many grams of water is produced from 1.5 gram of glucose? Our final answer was 0.90 gram water. Now let us go for a mass-volume relationship. For the mass-volume relationship, we have 4.0 grams of baking soda or sodium bicarbonate decomposed, heated, and that produce a product of sodium carbonate, water, and carbon dioxide. To balance the equation, we're writing 2 before sodium bicarbonate. The given is 4.0 gram, and we're looking for the volume of the gas, which is carbon dioxide. Now let us consider the coefficient of the reactant. So we have 2 molecules of sodium bicarbonate, 1 molecule of sodium carbonate, 1 molecule of water, and 1 molecule of carbon dioxide. For the mass-volume relationship, we need to consider the mass, the molar weight of sodium bicarbonate. The molar weight per molecule of our sodium bicarbonate is 84 grams. And for the volume, we will consider the standard 1 molecule of Amadeo Bugado, which is 22.4 liters of gas. We have a given of 4.0 gram sodium bicarbonate. We have 84 grams sodium bicarbonate. 84 grams per molecule of this reactant. And then for the balancing, we have 2 molecules of sodium bicarbonate to the unknown 1 molecule of carbon dioxide. We are looking for the volume of carbon dioxide. So 22.4 liters of carbon dioxide per molecule is given to reach the volume of the gas. This is equivalent to 0.53 liters of carbon dioxide.